Welcome to Wolves Marina channel. Thank you for being here. Today we're gonna talk about schematics. How do you make schematics from a mathematical notation or expression? So we know, let's jump on that I have a system where my F is an output is AB. AB means multiply means AND gate, plus means OR gate, and if it's this thing over, let's say for here is some, we are taking A, but if it's this thing or this thing, that means not, right? So if I have this system here, F AB shows that I have two inputs, and multiply means AND gate, A B gives me F. That's simply how we draw for a simple gate, or you can say like that. But let's just make and something things a little difficult. We want something like this, let's say. So this thing is G is my output, and this whole I have to draw. Well, what happening here is pick up the first element A, and then have B, C, and then we have C, A. So what we do, check out how many variables are there. Here's A, here's B, C. So there are three. So when you draw, you write down like this: A first, B first, C. Make a wire going like this. This is a wire. Let's say this is a wire. Okay. So check the first element in this equation. It's AB, means AND gate, means multiplication of A and B, means AB. So I take A from here, make a joint here so it shows that it's coming from A. This means overlap. If I make a dot, this means it's starting from here, or it's connected to this point. This is my AB here. Okay. The next one is BC. So what I can do is I take B from here and C from here. BC. I'm making like this because it's a more simple form. It's easier to read. For if I go to someone who makes chips or design chips, I can give him this schematic and he can make this thing, so it will be easier for him to look. So we are done with BC as well. Sorry, we are done with this also. Next one is CA. Well, means C and A are going together in an AND gate. Well, we are not done yet. This is our first element, this is our second element, this is our third element, you can say. So we have to OR all of them. So what happens, we have AB, we have BC. So the output of AB, the output of BC, and the output of CA, we simply gonna OR them, means add them. So for adding them we need OR gate. Ta-da, that's it. That's G there, your output. So if I go to the schematics guy, if I show this schematics to the designer, it will be easier for him to design this thing. Let's take a few more examples now. I have another system here. It's F here, A naught B, B naught C, plus A B C. Okay, let's start with it. How many of the variables are there? There's A, there's B, there's C. We'll deal with this not later, but how many there are? A, B, C. Simply just write down. Make three lines representing three wires from here. Okay, now the first element is A naught multiplied by B. So we have a A here, So just to make a naught, what we can do here is drag a line, or you can say take a wire out from here, from A is going in this NOT gate. Ta-da! This is my A naught ready. What else? Do we need a B naught? Yes, we need a B naught as well. So here I take out my B naught, not taking out like taking simultaneously the B. My B naught is ready now. Do we need a C naught? No, we don't. So the first element of this equation is A not B. So what I do this time, I'll not take from A, this time I'll take from A naught, and B will simply AND them. Okay, first one is done. Let's pick up the second one, that's B not C. Picking up B naught, not B, B naught, and simply C. So the second element is ready as well. Okay, and the last one is A, B, C, means all the three are going into an AND gate. A, B, and C. All three going in an AND gate. Okay, we have all of them. Now what's the last step to do? Let's do add them. So simply to add them all, we will OR first, OR them. It's similar like mathematics, you do multiplication first then add, so you have to follow the same technique here, right? That's it. Let's take one more example to it. So we have, let's call G A B C plus A naught B naught C plus C D plus A D C. This is the last example for today, and let's see what we have to make from this one. So how many variables? A, B, C, we have a D, 4 this time. Okay, not a problem for us. We're gonna draw it. We know the basics, we're gonna deal with it. Easy. The first element is ABC of this equation. So A, B, C. These all are in multiplication. That means these all are going in an AND gate. So ABC is ready. And then I'm sorry, I forgot one thing, that's preparing the NOT gates. So we need NOT gates in this one. So we need a NOT. Remember that this is not connected, is overlapping them. Or you can just think like this wire is going like this. Yeah. Okay, we need a naught. Do we need a B naught? Yes, we do. So just make it inverter for B. Do we need a C naught? No, we don't need. Do we need a D naught? No. So moving on, another element is A naught, B naught, C. So taking from A naught, taking the wire from B naught, and taking the wire from C, and multiplying them. So that gives you A naught, B naught, C. And the third one is CD. Easy. 2 inputs going into an AND gate. And the last one is ADC. A. You get a wire from D, and you get a wire from C. So we have all AND gates ready. Now the last step is to OR them. To OR them, we need to just make an OR gate. That's ready. That's it. That will be the schematics for this particular diagram. In the next class, we will be learning about how to convert decimals to binary, binary to hexagonal and octagonal. We're gonna learn about the number system, which will be very helpful in the near future. See you. Take care.